okay? But I don't usually use P and R because I like to use something that's going to help us out a little bit better. What I mean by that is I'm going to use E and I. Okay, so why would I use E and I? I'm using E and I because A, there's a jingle that goes along with it, and also because it's actually what it means, okay? A lot of times in math that you'll come across a problem and they use all these random variables. You're like, well, if it's a variable, why can't you use what it actually stands for so that I can remember it better, okay? So for example, E stands for exponent here. I stands for index. So instead of using Q and R, why not use E and I? So what that means is I can rewrite this as my index goes here, which is where it's supposed to go, and my exponent goes here. And the little jingle, of course, that goes along with it is, Old MacDonald had a farm, E-I-E-I-O. So that helps you remember which one goes on top. E goes on top, then I, okay? So exponent over index. We are going to rewrite these back and forth. That's going to help us when we're solving and also with logarithms, okay? Same thing down here. If I have A raised to the negative E over I, I'm going to write that as a fraction because of our exponent properties. And it'll become a positive. And I have it written like that, okay? We're going to be changing these from rational exponents to radicals and radicals to rational exponents. Okay? The only thing bad about this lesson is these little exponents are so small. Okay. So the first three problems, we are going to rewrite these as rational exponents. Number one is one that you need to become very familiar with because that's the one we're probably going to use the most in logarithms. Okay? So when nothing is written with the radical, what's my index? 2. And if nothing's written as an exponent, what is that? 1. So if I'm rewriting this, I do my exponent over my index. So x raised to the 1/2 is the same thing as the square root. Okay? Go ahead and try the other two. Okay, so if my exponent is 1, I can rewrite that as x to the 1/3. And over here, I can rewrite this as x to the 2/3. So it helps you remember, again, Old MacDonald had a farm, E-I-E-I-O. Helps you remember to put your exponent over your index. Okay? So now we're going to go backwards. Best way to learn something is you can do it forwards and backwards. So if I have my exponent over my index, this one I have the 4th root of x cubed. So go ahead and try the other two. And that's a little negative number right there. That's a little negative on number 6. They're both x to the 1/2, but 6 has a negative with it. Okay, so like I said, you need to get very comfortable with number 5. You don't even need to put the 1 or the 2. They don't need to belong there. That would be silly to put the 2 for a square root and a 1 for x to the first power. Same thing here. This becomes 1 over x to the 1/2, which means this is 1 over the square root of x. If they did ask you to rationalize that, again, we would just simply multiply by the square root of x over the square root of x. Okay? So, that's switching between rational exponents and radicals. Okay? You'll see if you looked in your book, there's another way that they actually write the first change. Okay? So, you might see it written this way, or you might see it written that way. It means the same thing. Let me see that person there. Is that just me? I see ghosts. Ooh. So that means the same exact thing. All right. And let's look at an example of that. If I had the square root of 4 cubed. Okay. So if I did 4 times 4 times 4, and then I took the square root of that, okay, I would get the same answer if I found what the square root of 4 was cubed. In other words, I should get 8. Okay? Those mean the same thing. I can have that exponent on the outside or the inside. It doesn't matter. Okay? So the reason why I share that with you is you're going to do all of these on this next page without a calculator. Let me make this bigger again. If you can't see the bottom ones down here, this is 0.6. This is 32 to 0.6. This is 2.5. And that's negative 1.5. Okay? So without a calculator, evaluate all of these. Make sure you are not using a calculator. If you need help with seeing them too, let me know. If you're like, is that a 3 or a 2 or whatever, let me know. I know it's hard to read. Remember in the good old days when y'all would say, I used to like math until they put letters in it. And then now you're all like, these numbers are tough. It's a lot easier to do these with variables than it is actual numbers. right, let's check a couple of these out. So like I said, you can write it where the exponent is inside, or you can write it where the exponent is on the outside. Some of these, you might have found that it was super easy to do it on the outside. Okay, so for example, for the first one, if I have the square root of 9 cubed, it's a whole lot easier to say what's the square root of 9 and then cube it. Okay, so we know that 3 cubed gives me 27. Some of us might have said, if I have 3 9s underneath the radical, I know I have a pair and then 1 left over. So I could have taken the pair out, which means the 9 comes out, and then I'm still left with the square root of 9. So then 9 times 3 still gets me 27. There's different ways to approach these. Okay. So the next one, I have 1 over the 5th root of 32 squared. Okay. Without a calculator, what is the 5th root of 32? 2. Okay. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay. So then I would have 1 over 2 squared, which is just 1/4. Hopefully you're catching on to how to approach these. Okay. We have the square root of 16 to the 5th power. Square root of 16 we know to be 4. And then from there, we got to get a little creative. If we wanted to do 4 times 4, which is 16, and then do another 4 times 4, which is also 16, and multiply your 16 times 16, which should have gotten you 256, times another 16, or another 4, sorry. What was it, 1024? What y'all got? Okay. Or you could have just done 4 times 4, which is 16, times 4, times 4, times 4. It doesn't matter, okay? All right, so number 10, this is 1 over the cubed root of 64 squared. What is the cubed root of 64? 4. 4 squared gets me 1 over 16. Okay. The next one, that means it is the 4th root of 1 over 16. What's the 4th root of 1? 1, not a trick question. 4th root of 16? 2. So just 1/2. Okay. We've got negative 27, which is super important to keep in parentheses. We've got the cubed root of that squared. So if we find the cubed root of negative 27, we still get negative 3, but then negative 3 squared should get me a positive 9. Okay? So do not forget those parentheses. Do not. Okay? Are there any questions on the first 6? Any questions on the first 6? Yeah.
Why would 27 not become 9?
It is an odd index.
Right.
So if I do negative 3 times negative 3, that's a positive 9, times another negative 3, that's negative 27. So that's legal if it's odd.
I forgot
that. Oh, come on. There we go. All right. So if I think about 0.6, that's the same thing as 6/10. Okay? Which reduces to what? 3/5. So 32 raised to the 3/5. That means it's the 5th root of 32 cubed. We already talked about what the 5th root of 32 is. We said it was 2, and 2 cubed gets me 8. So even decimals, you just got to convert them to fractions, and then you can go from there. All right. 2.5, we can rewrite that as 5/2. So then that's the square root of 100 raised to the 5th power, which means 10 raised to the 5th power. How many zeros we got? 5. Okay, and then finally our last one, if I have 1/64 raised to the 3/2, another way to write 1.5. It's the same thing as 1 over the square root of 64 cubed, which means 8 cubed. So then 64 times 8, 48. 1, my mind wasn't going there. Okay. So again, we've got to be a little bit more comfortable with being able to do some mental math or some old school math if needed. Okay? Any questions on these 9 problems? Okay. Let's take a quick break. Then we're going to take a trip back to Algebra 1 that y'all seem to not hold on to.
I usually
Is my mic okay?
That's why I feel like the first, like, 2 2 weeks of us being in school, I would come in there and morning and go, oh,
I've been carrying bench for like 4 years, but I stopped.
Oh, really?
Yeah.
Good
why
thing
did you
to,
start?
good thing to do.
I thought it'd be like 4, you only do 1.
All right, let's come back. Knock the rest of this out. So like I said, we're going to go back to Algebra 1 for a minute. You can rattle them off and you can tell me all about them, but then when they actually show up, y'all are like, I don't know what to do. And those are those exponent properties. Okay? Kind of like when that negative just appeared out of nowhere a couple lessons ago, and y'all are like, what do we do with a negative exponent? Okay? All of these exponent properties, like I said, y'all know them, y'all have seen them before, but then magically a problem will show up and you're like, I don't even know how to approach it. Okay? So when we are multiplying with the same base, what do we do to our exponents? Add them. Okay? If we're raising a power to a power, what do we do to our exponents? Multiply them. Like I said, y'all can rattle these off all day long. But then as soon as a problem shows up, y'all are like, I don't know what to do. Make sure we are back on math. And we are still working on other stuff. Okay? If we have two things being multiplied together and an exponent, what do we do? Okay, so this is where the problem happens, I think, because we're used to this. And then when something like this pops up, we so badly want to do that. Okay? So notice the difference. That has a plus sign. This does not. Okay? So when people say we're distributing the exponent, you're basically just applying the exponent to both pieces. In other words, it would be AB times AB if it was AB squared. Okay? All right? We've seen this one a handful of times. This is 1 over A to the M. And then don't forget, if it's 1 over A to the negative M, that moves to the numerator and becomes a positive there. Okay? What do we do if we are dividing? Subtract. Another mistake a lot of students make. So you have 4 to the third power over 4 to the second power. Y'all are so used to saying if I see 4 over 4, that's 1, and so I have 1 to the first power, so my answer is 1. That's not how that works. Notice how my base is staying the same. So 1, what y'all would say, versus if I had 4 over 4 squared, that is 4 to the 3 minus 2, which is 4. So that's a big difference. You don't change the base. Okay? And our last one, same thing as if we were multiplying, we're going to apply that exponent to both the numerator and the denominator. Okay? So again, all of these properties we have seen before, we have used before, and then I switch to the next slide and y'all are like, I don't even know what to do. Okay? It happens. I get it. That's why we're reviewing them. Even my pre-cal kids. They're like, I don't know what to do here. Okay. Which I think some of y'all are doubling up on. I think I'll have you in class next semester. All right, so let's give these a shot. Let's try the first row first. Not get too carried away here. Let me make this bigger. There we go. Okay, go ahead and simplify. If it can be completely simplified, go for it. I will be specific on what I want y'all to do in regards to your answer on like a test or a quiz. Speaking of which, your quiz tomorrow, y'all will have a quiz on just operations of radicals. So simplifying, multiplying, dividing, adding, and subtracting. Okay. Your quiz tomorrow is just operations of radicals, not the stuff we've done today. You can actually see which one you're pressing down. All right, so the first one, we have the same base, so I'm going to keep that the same. And I have 1/2 plus 1/4. Okay, which will give me 3/4. And like I said, depending on if they say to leave it in simplest radical form, you would just write it like that. If they tell you to leave it as a rational exponent, you would leave it like that. So like I said, if I'm not picky on how I want my answer to be written, then I can't be picky on grading your answers, okay? I think in the book, they do it one way. If you're not sure, you can always check in the back of the book for answers to see how they want it. But again, like I said, if I'm not picky on it, I can't be picky grading it. All right, so if I apply the 2 to each piece, I end up with 8 to the first power, because 1/2 times 2. And then 5 to the 2/3. So then I end up with 8 times the cubed root of 5 squared, or I could write that as 8 times the cubed root of 25. Again, if they tell you to leave it with the exponents, then you could have stopped up above. Okay? Couple different ways you can look at number 3. You can look at number 3 and say, oh, that's 1/3. That's like the cubed root. Okay? Some of y'all may have applied the negative with each one. For me personally, if I see a negative in the set of parentheses like that, I'm going to deal with the negative first. So what I'm going to do is I'm going to bump everything to the denominator and make it a positive. So that way I don't have to deal with the negative anymore. I'm done with it. Okay? So then now if I apply that 1/3 to each piece, I end up with 1/4 to the first and 2 to the first, which is just 1/8. Okay? So again, exponent properties, we can list them off. It's easier if I gave you variables. It's harder with numbers, but I want to make sure that y'all know how to do those. Any questions on those 3 so far? And there's multiple ways y'all could have approached those. So don't feel like if my way isn't the same as yours, that you got the same answer. Remember, I'm not a my way is the highway kind of teacher.
Thank you.
My way or the highway is what I meant to say. Instead of my way is the highway. All right, try these 3. All right, let's go through these three. So we've got 6 to the first power over 6 to the 3/4. So we're going to subtract our exponents, which means 6 to the 1/4, which is the 4th root of 6. Again, depending on what they want you to write as their answer, then you'll leave it like that. Okay? So there's a couple different ways you can approach this next one. If you notice, 1/4 and 1/4 are the same, which means I could technically write this as the 4th root of 18 over 9 cubed. 18 over 9 reduces to 2. So then I have the 4th root of 2 cubed, which is just the 4th root of 8. Okay? Now, if you applied it, you could also change 18 to 9 squared to make them have the same base. Again, like I said, there's multiple ways to approach it. The next one, I want y'all to get familiar with 1/2. 1/2 square root, 1/2 square root. That's what it means. All right, so one way to approach this one is that I can look at it and say, well, this is the square root of 9x to the 4 y to the negative 2. Well, the negative needs to be in the denominator. So I can write that as 9x to the 4th over y squared. And conveniently, those are all things that can take the square root of. Square root of 9 is just 3. Square root of x to the 4th is x squared. And then over y. Let me scroll up so some of y'all can see this in the back. There we go. Could you have done it a different way? Absolutely. You could have applied that 1/2 all the way through, and you still would have gotten the same answer. You just cannot leave a negative exponent as your final answer. Okay? Any questions on those three? All right?
Yeah, I'm good.
Did that sneeze?
Yeah.
Bless you. I didn't know if it was a cough. I'm so used to seeing kids cough like that, and I'm like, bless you, and they're like, it was a cough.
I love all the people that take down their mask to cough.
Yeah.
Like, what's the point?
Last three. Knock these out. Last three. Okay, let's go through these really quickly. All right, so if we're multiplying with the same base, we are going to add. We've got 2/5 plus 3/8. If you want to make your life simple on yourself, you can just multiply by 8 here and 5 here, make them both under 40. So 2/5 plus 3/8. So we have 16 plus 15 all over 40, which gets me 31 over 40. And of course, that would be the 40th root of y to the 31st if they asked you to switch it, which is weird, but doable. The next one, we're subtracting. So we have 4/7 minus 2/3. So 4/7 minus 2/3. I can multiply by 3, multiply by 7. And so I end up with 12 minus 14, which is a -2 over 21. Can't leave a negative exponent as our final answer. So technically, this one should be 1 over x to the 2 over 21. But if I have to rewrite that as a radical, that means there is a radical in the denominator. Okay? So this would be 1 over the 21st root of x squared. And if they wanted you to rationalize, I'm just throwing out all the possibilities here. Never seen a state test. Just making sure we're all prepared. We have 2 x's and we need 21. How many are we missing? 19. So technically I could multiply It looks weird, it's crazy, but if they make you take it that far, I don't know that they will, but like I said, I've never seen this state test. Okay. And our last one. I'm going to do 2 times 6, which gets me my 12. And then I'm going to add my exponents. So 2/5 plus 1/4. Multiply that by 5. Multiply that by 4. I get 8 plus 5, which is 13 over 20. And if they wanted me to rewrite that, I would have the 20th root of x to the 13th. So again, depending on how they ask you to leave your answers, that's how you'll do those. We made it. We did it. Okay. But like I said, what we're actually going to be using these, switching from rational exponents to radicals and backwards, is something we're going to use in solving, and we're also going to use in logarithms, which is our next chapter. Okay, so this is just a stepping stone for what we have to do later. Okay, so your homework is 6.